3.5. Today we're going to start talking about logarithms a little bit. And I need to freeze my aspect ratio and go from there. Logarithms are one of those things that people find very scary, and I'm sorry it is. What we're going to do with them is actually just the easy part. We're not going to be solving these things. We're not going to be dealing with them too much. We're basically just going to be turning them into and out of logarithms. Just the biggest thing we're going to do. But a logarithm, in its essence, is simply it's a function that basically exposes an exponent. It's basically a way to get to an exponent. So if you have something like, let's say you've got the equation 5 to the x equals 12. All right? I do not, 5 to 12. I have no idea what power 5 has to have in order to equal 12. I know 5 to the 1 is 5, 5 to the second is 25, but what will give me that 12? A logarithm basically turns it into something that looks like this. Log base 5 of 12 equals x, and that is something I can calculate. Now we're not going to be calculating anything along those lines, but this is what it is, okay? And it seems foreign right now, but just go with it. Okay? A natural log is a log, that's not an A, that's an O, is a log with base E. Now, E is much like pi. It's like 2.77 ... It's one of those numbers that goes on forever and ever and ever and ever till death do us part, that sort of thing. And it's used a lot in the sciences, and it's used a lot in, actually more in accounting purposes than anything else. Your banker really uses that a lot. But anyways, here's the point. If you have e to the power of x, let's say e to the x equals 5. I have no idea what that x is. It is used so much, it gets its own logarithm. Okay? And so it is ln of 5 equals x. It's like having a little understood e down there. Okay? But we don't have to write it. It is just understood. But it's so common to have a log base e that it gets its own logarithm status. Follow me? All right. There's people still writing. Keep writing, and then we'll slide on down and keep finishing up. All right? All right, here we go. Let's start off by talking about turning them into and out of logarithms, okay? So, first things first. I'm going to do something I call it popcorn because it kind of looks like a popcorn. If you had to look at letter A, and you picked one of those numbers was to be the base, what would you think? The 2, the x, or the 32? What might you think was the base?
32.
The 2. Well, think of it this way. Which is the only one that has something on top of it? The 2. All right, so that's your base. You start there, you go across the exponent over to there, and come back, go across the equal sign to the exponent. Okay, so it is log base 2, and we're going to write that 2 nice, low, and small, of 32, we'll be back up to the normal size, equals x. Okay, start with the 2, go across the equal sign, and come back. You don't have to understand why that is. I'm not even sure I understand why that is. It's just what it is. Okay? Come on, you two. All right, same thing for letter B. I'll change colors. Here we go. Your base for letter B. What do you think your base is for letter B?
X.
The x. Good. Start with the x. Go across the equal sign and then come back to the exponent. So it's log base negative 3. Oh, base x, I'm sorry. Of 1/16 equals negative 3. Okay? Log base x of 1/16 is negative 3. We went across and then came back. Come on, you three. Let's chill out. And you don't even have stuff on your desk. Yeah, let's go. Let's do that. All right, so, and again, we call this popcorn just because that kind of looks like a piece of popcorn right there. That's the only reason. All right. Letter C. What's the base for letter C? E. But remember, log base E is ln. So we're just going to write E for x. ln of 4 equals x. And that's bouncing all over the place. Try that again. Cool? What is that about? Why is it telling me to do that? No. All right. Try letter D. Try letter D on your own. D, E, and F. Just knock them out real fast. All right, whenever you're done, look up, see how you did. Did you grab the correct base? Did you write it nice and low? All right, well, let's see. Even if you're like, I know some people physically cannot write small. I understand that. So for these, if you can't write small, try and write it below the line. Does that make sense? That way you can distinguish what's a base and what's actually the normal argument in there. Okay? But any questions about this so far? All right, let's slow down. Example 2. Write the logarithms as exponentials. Oh, hey, guess what? It's the same stinking thing. Start with your base, which in this case, for letter A, what would your base be? 4. It's that nice little number. Go across the equal sign and then come back. So it's 4 to the x equals 3. What would your base be for letter X? For letter B? X. Go across and come back. So x to the what? Negative 4 equals 1/5. All right, last but not least, letter C. What is your base for letter C? E. Good. Remember there's a little understood E down there. So it's e to the what power? Equals 7. Good. All right. Try the next 3. Take a second and knock the next 3 out real fast. All right, whenever you're done, look up, see how you did. All right. And again, like I said, it's the exact same popcorn thing. Start with your base, go across, and come back. Start with your base, go across, come back. Start with your base, go across, come back. Even if it's written the other direction, if you've got ln of 7 equals 9, okay, start with your base right there. Go across and come back. So that's e to the 9 equals 7, which this is actually not a true statement, but that would be the pattern you follow. E to the 9 does not actually equal 7. But anyways, how am I doing this? Give me a 5 to 1. 5 I got this 4, okay, 3 and 2 lost. 1 statement. Okay? Well, yeah, but that's not because it's that difficult. Follow me? All right, cool. All right, turn the page. All right, so here's how we're actually going to use these. It says generate the inverse of the following exponential functions. Generate the inverse of the following exponential functions. All right, so for an inverse, what's the first thing you always do for an inverse? Switch your x and y. So I'm going to start off x equals 1/5 e to the, and I'm going to put the exponent in parentheses, y plus 1 plus 1. All right? That way, it's just easier for me to see it that way, because what I need you to do is I need you to be able to see this piece right here, kind of like you saw x plus 1 cubed in the last section. Okay? That's the piece you got to whittle down to. So to get down to that, what do we need to get rid of first? The 1, and then what? The 1/5. Okay, so if we get rid of the 1, how do we get rid of the 1? Subtract it. So we get x minus 1 equals 1/5 e to the y plus 1. All right? All right, how do you get rid of the 1/5? Say again? Multiply by what? 5, exactly. So we'll multiply both sides by 5. Here, let's use a different color so it's easier to see. And you don't have to, but I'm going to go ahead and distribute it on the left. And when I do that, what do you get? 5x minus 5 equals, and bring everything down. 1/5. Nope, the 1/5 is gone. Sorry. Back up, back up. Come on. There we go, Bessie. E to the y plus 1. All right, everybody cool with that so far? All right, this is where we use our popcorn, turn it into a log. Okay, so we're going to start with the base. We're going to go across and grab the entire thing, and then come back to the exponent and grab the entire thing. All right, so it's not just grabbing one number. You grab everything over there. You grab everything in the exponent. Okay, so first things first. Log base e. How do we write log base e again? ln. Good. So ln of 5x minus 5 equals y plus 1. Cool. Take your base, go all the way, grab everything on the other side, and then go over and grab everything in your exponent. All right? And then what's the last thing you got to do? Subtract 1. All right? And again, I'm going to stick it out front. But if you did this, you stick it out back, that's fine too. It's just typically considered proper to put the logs last, but you don't have to. Just like we put the square roots last in the last section, you just don't have to. All right? Any questions so far? Comments, complaints, public service announcements, bad jokes. Not dirty jokes, bad jokes. All right, let's try the next one. All right, letter B. First things first, what are you going to do? Switch what? X and Y. So we got x equals 4 to the 2y minus 3 minus 9. Okay? Walk me through it. What are you going to do next? Add what? The 9. Cool. All right. Where are we going to go from here? Okay, which is, we're going to turn it into a what? To a what? A logarithm, a log. So start with base what? What's your base in this case? 4. Okay, so log base 4. And we'll write that 4, nice, small, and low. Of what? What are we going to put next? Good. X plus 9 equals what? 2y minus 3. Good. Started off with the 4, went across to the other side, and then came back to the exponent. All right? And then from here, it's just stuff you're used to doing. What's the last thing? The next thing you're going to do? Well, not subtract the 3, but add the 3. It's a negative 3, so it becomes positive. So 3 plus log base 4 of x plus 9 equals 2y. And then what's the last thing you got to do? Divide by 2. And so we're going to take the entire thing, log base 4 of x plus 9, and divide it by 2. And yeah, it's a big, kind of an ugly answer. But so what? Another way to write this, if you didn't want to write it as a big fraction, you could write it as 3/2 plus 1/2 the log of everything else. I basically just treated these as 2 fractions. If you wanted it, if you saw it like that, that's fine. Not that you have to. It's just a way of seeing it, that's all. All right, but how are we doing this? Give me 5 to 1. 5, I got this easy peasy. 4, I'm okay. 3 and 2, I'm lost. 1, can it be nap time? Wow, nobody responded to that either. Are we alive? All right. All right. You think you can do letter C on your own? You think you can do letter C? I think you can. Give it a shot. Give letter C a shot. All right. Oh, pause the video.
All of that. All of that. Yep, that's what I said. Exactly.
Is it possible to email your counselors on the phone?
I don't see why not. You just got to know their email address. I mean, if your cell phone is set up to send an email address, yeah. Send an email, yeah. All right, any questions on letter C? Anything you want to talk about? All right, really the only new part to this is A, getting used to seeing something with a big exponent. That's okay. That's just like getting used to seeing, you know, the giant square root that looks like that. Oh, but it's cubed. It's okay, you get used to that. And it's also getting used to, hey, turning this into that, going from the exponential into the logarithm. All right? And that's the new part. And yeah, it looks a little foreign. I completely understand that. And no, you don't need to understand why this is true. You just need to do it. Follow me? Sometimes, like, how many times do you understand everything your mom is asking you to do? Most of the time, yeah, but every so often your mom asks you to do something, you're like, what? You want me to do what? You just go with it. All right? This is one of those times. All right? All right. Let's keep rolling. I'm going to leave letter D. Let's talk about verifying these real quick. All right, so if you have to verify them, all right, first things first, just like before, find the inverse of one and see if it equals the other, just like we've done before. All right, so switch your x and y and solve. Okay, so we'll work this one out together real quick. So for letter A, switch your x and y. We got x equals -3 times 10 to the y minus 2. All right, and walk me through it. What do you do first? Plus 2. So we got x plus 2 equals -3 times 10 to the y. Okay, what are you going to do next? Divide by what? Just the 3? Take the negative with it. Yeah, if you got a negative in front of it, take the whole piece. So we'll stick it right there. X plus 2 over -3 equals 10 to the y. Cool? All right, there's nothing going on over here. So log base what for this one? 10. Which log base 10 is so common that we actually don't have to write the base. It's kind of like if there's an x right here, what's the coefficient in front of it? It's a 1, right? Well, if you have a log with no base, it is an understood 10, so you don't have to write it. If you do, that's okay, but understand, if there's no number there, it is a 10. All right, it is a 10. And that's because log base 10 happens so much in science that it's become understood. All right, so log base 10 of, helps to use a pen, not an eraser, x plus 2 over -3 equals y. And the question is this the same thing as that? What do you think? Well, let me ask you this. If I were to split, okay, so you got x plus 2 over -3. Well, that really is an an x over negative 3 and a 2 over negative 3, is that negative 1/3 x? Yeah, it is. Is 2 over negative 3 negative 2/3? Yeah. So it is the same thing. It's just written a little different. All right. So if anything, these are going to kind of stretch your, yeah, that's the same thing. It just looks a little different. All right. But you got to be ready for that. So this one's a yes. Cool. Let's keep rolling. Next page. I'm going to burn through this real fast. Letter B. Are these inverses? Okay, so yeah, you're going to get some errors. This is the logarithm one. That's okay. Logarithm has some errors on it. All right, so just look for the x's and y's you have in common. So like I've got a 0 on the left and a 0 on the right. Do they have the same number to go with it? Yep, okay, so that one's good. I got a 3 on the left and a 3 on the right. Do those have the same number? Yeah. So is it reasonable to assume these are inverses? Yeah, it's reasonable. Is it proof? No. But is it reasonable to assume so? We have seen no evidence to the contrary. All right. Same with letter C. Y'all done these ones before. All right. Believe it or not, an exponential, this is actually your logarithmic function right there. It kind of looks like, you know, a slope that goes and just goes straight down forever and ever and ever. Amen. So, do those reflect across that 45-degree angle? Are those inverses of each other? This one's a little tricky. I'll give you a hint. Do they reflect across a 45-degree angle? They do, but is that the one we want? No, we want the one that goes right through the origin, right there. So yes, they're related. No, they're not inverses. Okay, they would reflect over here instead. So the answer in this case is no. They reflect across the wrong line. Cool? Does that make sense? You have them before? Yes, ma'am. All right, last thing on last, and then I'm just going to kind of turn you loose. Slide on down. One thing that this page does not do is give you the rules. So we're going to write that down real quick. Rules. And so we've got a y equals a of a log bx minus c plus d. Okay, so there's your basic form. And the parent function is y equals log of 2. Okay, y of log of 2. And this is what they look like. If I have my x and y axis, they look like this. It comes right up on that axis, comes across right there, and goes on forever. That's what they look like. Cool? So we just need to give you the rules. So let's write those down. We're just going to write them down real quick, and I'm going to call it a lot. So we have, we're going to have a vertical asymptote, a V-A-S-Y-M-P-T-O-T-E. We have a domain. We have a range. And then you have intercepts as well. Okay? Now, this may or may not have all the intercepts. Like, it might not cross the y-axis. Very possible. So here we go. Your vertical asymptote. Your vertical asymptote is at x equals c divided by b. Okay? And again, you may not have a b value, you may not have a c value, but so in the case of the parent function is x equals 0. So that's where this one is. It's got an asymptote right there that it goes up against but never touches. All right? Your domain. you've got two ways of writing it. In interval notation, it's from C over B to infinity. That's the positive way. If you have a negative, like if your A value is negative, it goes from negative infinity to C over B with a parentheses, because that's where the asymptote is. So basically what I'm saying is the graph either goes like that or it goes like that, one or the other. Either goes to the left or the right. All right? And so you have your set builder. X is either greater than C over B or X is less than C over B. Cool? Your range, well, it goes down forever and it goes up forever. So your range for all of these is all real numbers. That's the easy one to remember. So when it asks you what the domain is, great. You just got to know, is A positive or negative? You just say this is A positive, A negative. And which way it goes. The range for these is what? All real numbers. Cool? And those are your rules for this. And we're going to call it quits. Cool? You want to start your homework, you're more than welcome to, but we're going to start it tomorrow as well, and we'll make sure we're all on the same page. Okay? I understand these ones are a little funkier. It's all right. You'll survive.